Hi everybody, welcome to another one of my conference presentations. This presentation takes us all the way back to 2012 and the 25th ARRB conference. And this paper is about programs. And the title of the paper is Road Program Evaluation, Assessing the Bigger Picture. So why should we investigate program evaluation? What's wrong with just looking at projects individually? You think about it though. If you look at transport and road projects, there are so many of them, especially when you're looking at a country like Australia. There's a vast network, and you look at a state like Queensland, it's got a very large network. And then you're going to need many, many projects in order to maintain that network, in order to improve that network. And simply just looking at individual projects by themselves is very time consuming and also be very costly. And also, if you're going to focus on individual projects as well, you may not have the quality of the analysis as well if you're rushing through that. So the advantage of having it as a program is you can actually pull all these projects together and look at it as just one program. Another factor to consider as well is that these projects are often interrelated, especially if they're within the same geographical area. For example, you may have a flooded road. It may be flooded in 4 or 5 places. If you look at just each individual flood project along that link, you won't be covering off on the whole link in itself or even other parts of the network when they influence each other. So it's actually important for projects, especially flooding, to actually have a look at them in terms of a network. The same thing goes with bypasses as well. A bypass may involve several projects in itself. You may have the bypass. You also may have upgrades to the existing road as well. To separate them is not logical in the sense that there is a relationship. So if you build a bypass, your traffic through the town would have improved. So you'd have to factor that in if you're upgrading an intersection in the town. So looking at programs is quite important, not just in terms of saving time and money, but also in terms of improving your analysis and your quality of your analysis. As part of this research, we investigated a number of existing models. Like we've got here, the Nemhauser and Ullman model. This model looks fairly sophisticated, but actually isn't that difficult. The concept is fairly simple. So what this is about is you need to maximize your benefits given a particular constraint. So that would be your capital cost or just your overall costs. So the aim is to get the highest amount of benefit for the constrained capital you have. And that is actually very similar to what you have when you look at projects. So for example, you have a benefit cost ratio for a project. So the project with the highest benefit cost ratio is considered the better project. In this case, it's a combination of projects or the combined benefits of all the projects compared to the combined cost, and your cost is actually your constraint. And this is very similar to what we will be looking at later on. There's also a number of other models I won't go into today. One is by Gear and Cow in 1980 and Tao and Sconfield 2006. So how can we utilize these methodologies? How can we resolve the limitations? And what customization is required in order to get these ideas, these concepts, into actual practice? So what I came up with was 2 possible solutions. One I call the simultaneous approach, and the other one I call the sequential approach. And I'll be explaining those 2 approaches in this paper. First, let me explain what I mean by the simultaneous approach. So, as like with a project, you have a base case and you have a project case. In the base case, we assume that none of the projects are constructed. So the program does not go ahead full stop. And in the project case, we assume all the projects are constructed. So everything goes ahead. So you'll be comparing a scenario where nothing happens to a scenario where everything happens. So that would be the total benefits of the entire program, regardless, will be looked at in this way. And you also look at individual projects and see how they contribute to this total benefits. And then using that, we'd actually rank the projects accordingly. So which projects have the highest contribution per dollar spent will be those prioritized. This approach, though, has a number of limitations, and I'll be touching on those limitations a little bit later in this presentation. Let's now take a look at the sequential approach. This approach differs quite a bit from the simultaneous approach, in the sense that the simultaneous approach looks at all of your projects within one shot. The sequential approach is a little bit more complicated and also requires a pre-ranking of your projects. So we'll take your first project, for example. You would assume your base case that nothing's happening. That would be very similar to your simultaneous approach. But you only assume that one project is constructed. So your project case would be on the assumption that just that project is constructed. For your second rank project, the project case with the first project now becomes your base case. And now your project case is the construction of your first project and your second project. And this will continue on. So for example, you get to your 9th project. So your base case would be your first 8 projects, and your project case would now be your 8 plus your 9th, and what additional benefits that project gives you. So basically you're looking at the incremental benefit of adding each individual project based on a predetermined ranking. So again, this has its limitations. It's a bit more detail, but that ranking is actually quite essential because you can't actually conduct this approach if you do not have that ranking. So we'll have a look at the limitations of this a little bit later on. I have proposed 3 methods of incorporating a simultaneous approach and a sequential approach. Method A is just the simultaneous approach. So as I mentioned before, that is the base case without any of the projects in the program, and your project case, which includes all of your projects within the program. So what you do with these projects is you have to look at them individually. So you take each project and you calculate their benefit cost ratio, benefits divided by cost, or you could look at their net benefit investment ratio, which is your net benefits divided by your capital cost. I prefer the net benefit investment ratio as you're focusing on your capital spend at the moment and not looking at future costs. So I feel this is a better approach of ranking according to investment. So you use this net benefit investment ratio to rank your projects within the program. And you keep going until your capital runs out. So that goes back to the models we investigated earlier. The Ullman model, where you actually maximize your benefits for your capital cost spent. Another way of looking at it could be your incremental benefit investment ratio. That is if you've got options combined in there as well. So you may not just have projects within your program, you may have options and combinations of options. And you may want to compare those options using the incremental costs of each of those options. So again, the higher capital costs should have higher benefits, and do those benefits outweigh those additional costs? And you could have options within options as well. So you may have several combinations of options because they work with different options. So it could get fairly sophisticated. So potentially there could be quite a bit of evaluating. But in the essence of it though, it's about maximizing the benefits for the amount of capital available. Method B just utilizes the sequential approach. So before you can actually go to the sequential approach, there needs to be some method of determining a ranking. So I'm going to talk about a way that it can be done in method C. But for the purpose of this, let's just say you have something like a multi-criteria analysis. So through that multi-criteria analysis, you can rank your projects within the program. And once a ranking has been decided, then you can evaluate each project at a time, building on the base case. In a sense, by adding each project to the base case. You can look at this, and once you've completed it, you'll be able to assess whether you need to re-rank them accordingly. So for example, maybe your second project doesn't add much at all in terms of value, but maybe you have another project further down, your 6th project, that maybe adds quite a bit more. So you can actually use this to re-rank your projects and then run the analysis again. Potentially this could be quite a bit of work, so you'd have to hope that your multi-criteria analysis is fairly accurate so there isn't too much rearranging. But as with method A, again, you have to rely on your capital constraint, so you can't go beyond that. And also you'd use ranking methods, such as your net benefit investment ratio and benefit cost ratio, potentially to rearrange which projects it should be in there. But ultimately, you should be looking at maximizing those benefits per cost. Now we have method C, and method C is actually a combination of method A and B. So what we're proposing here is starting off with a simultaneous approach, and this is used to give us an initial ranking of our projects. So unlike what we said in method A, we rank them until your capital costs run out. In this case, you continue ranking them all the way through until the end of your project. So your capital costs may have run out by the time you reach project 12, for example, you may have 20 projects. So you continue ranking beyond that 12 and see where you land up, because the results using a sequential approach may be quite different. So now we use this ranking and we put it into the sequential approach. This can be a little bit more detailed and should be a little bit more realistic because we have project timings and all that. And what you should get with your sequential approach is confirmation of what you've done in your simultaneous approach, and you should be able to keep the same ranking. Again, if you have projects that are performing much better later on, you may want to rearrange them, and it may potentially change your ranking. And with this, like mentioned with the previous methods, you keep going and keep evaluating benefits until the capital costs have run out. So in a sense, it still goes back to that same concept of maximizing benefits for capital spent. So as part of this presentation, I have a number of case studies where the simultaneous approach and the sequential approach have been applied to programs. So the first case study I have here is the nation-building Bruce Highway Overtaking Lane program, otherwise known as the NBBHOL. And this program was between Curra and Childers, which is a 40-kilometer stretch. So a number of existing overtaking lanes on the stretch of road, but it was deemed that these overtaking lanes were not sufficient to deal with the current traffic flow and the current number of freight vehicles along that route. So as you can see from the diagram here, that the red, these are the proposed overtaking lanes, and they have what we call an upstream and a downstream area. The upstream area is the 3 kilometers before the overtaking lane, which we've assumed that vehicles will no longer try and overtake, and they will wait until the overtaking lane. Therefore, there'll be a number of safety benefits. The 5 kilometers downstream is the area we assume overtaking will not take place, as vehicles have already overtaken the slower vehicles, and there will be some passing of time before they reach the next heavy vehicle, though that would be only an average. By having a program, you can see that some of these upstream and downstream areas are not to the full extent of the 3 or 5 kilometers, given the proximity. So they've been adjusted accordingly. This wouldn't be possible if we had not used a program approach. Okay, so what was the results of this program? So altogether we had 9 projects, and we ranked them according to the benefit cost ratio. So we've got project 6, which had a benefit cost ratio of 7.92, which is ranked number 1. And we've got projects 4 and 5. They were combined, probably because of close proximity, so they're probably treated as head-to-head overtaking lanes. So they got a high BCR as well as 3.29. They're significantly lower than project 6. And we were kept ranking accordingly until we got to our lowest project, which is project 1, which only had a BCR of 1.29. The overall net present value for this program was over 55 million, and we also got a program benefit cost ratio of 2.66. Now bear in mind, at the program level, the benefit cost ratio is not as relevant as it is at the project level, because the benefit cost ratio is used for ranking of projects within a program. But at the actual program level, the most important indicator is probably your net present value, which gives you your total worth of your whole program. Our next case study is the Warrego Highway Upgrade Program. This is quite a substantial program with a capital expenditure of 670 million. The Warrego Highway goes out west from Toowoomba and beyond Roma, going very, very far. Most of those projects, though, were between Toowoomba and Roma. Quite a substantial number of those projects were. So you've got a total of 18 projects. And this was actually split between the cost-benefit analysis team of Transport and Main Roads and Economic Associates, a consultant that was brought in to help. The overall benefit cost ratio of the program was 2.69 at a discount rate of 4%, and the net present value was 808 million, and also at a discount rate of 4%. 12 of the 18 projects have benefit cost ratios of greater than 1. The Warrego Highway Upgrade Program consisted of a number of different types of projects. They varied from intersections to rail crossings to bridge upgrades, which involves improved flood immunity as well as improved strength so heavy freight vehicles can cross, as well as shoulder sealing and also projects to reduce congestion, which would be duplications and possibly bypasses. The sequential approach had actually been applied to this program, as there's already a pre-ranking of projects, and there was even timings as well for these projects had been announced. So some of them were within about a year of the evaluation, some of them going out to beyond 2020. So as you can see here, we've got the benefit cost ratios, and this is according to how they were previously ranked. So we got our first one. First off the rank was McAllister to Warra. That had a benefit cost ratio of 1.52. The next project was the Toowoomba intersections with only a benefit cost ratio of 0.26, so added very little value to the actual program, but was actually ranked very high up. You have some projects that are further down that should have actually been a much higher priority. Take, for example, all the way down to Carmichael and Wombo Streets. That project, I believe an intersection, got a benefit cost ratio of 7.89, which is actually quite high, and that probably should have been a higher priority. So you can see that the ranking prior to the sequential approach actually probably wasn't very reliable, as you got many projects later on that actually got fairly good benefit cost ratios, and some of the earlier ones that don't, which also includes the Marlou Quarry west of Bowenville, and you got some other good ones later on, which is Oakey to Dolby overtaking lanes that performed very well. And this was actually taken into consideration, and some of these projects are actually re-ranked later on using the benefit cost ratio that was actually produced from this program. I currently do not have an example of the application of method B, which is a combination of using the simultaneous approach initially, which is then followed by the sequential approach. So simultaneous approach that's used to rank initially, and then that ranking feeding into the sequential approach. And that approach is most likely to give you the most reliable results, but that's also going to be the most time consuming. But I'm hoping that that's going to be a way forward in the future, that approach is actually going to be adopted. As we saw, there were a number of problems with the Warragul Highway where the initial ranking using their previous method, whether it be multi-criteria analysis or not, was not consistent with the actual cost-benefit analysis, and therefore did not produce particularly good results, and therefore all had to be arranged according to the new benefit cost ratios that were determined. So let's now quickly summarize the disadvantages of the three methods. So we started with method A, the simultaneous approach. It's a fairly simple, fairly straightforward approach, but it's also fairly unrealistic. There's no project timings involved. It's not realistic to say that every single project is going to be built at the same time. So you've got simplicity, and then you've got that inaccuracy of not having proper timings. So how about method B, where now that we've actually got some project timings and we evaluate them in a more realistic fashion, in the sense that you would have your base case should actually include some of your previous projects, which is actually more realistic. So that may be more realistic, but if your ranking is not particularly good, then again you will lose some of that realism simply because your base cases for each step may not be accurate if you have to rearrange them. And if it is that inaccurate, then we may have to go back and actually reevaluate the whole program again using the sequential approach, using a new ranking. And that could be very time consuming. So how about our third method, the method that hasn't been used yet? So that would be using your simultaneous approach to come up with your initial ranking, be more of a rapid analysis, followed by the more detailed sequential approach. That in itself has a problem, as you're going to have to evaluate it twice. And again, that would be time consuming, and also the timing there has to be within a reasonable amount of time of each other, and also that requires doubling up of work. You do get the advantage though that you should have a fairly accurate ranking going into sequential approach, but if it requires maybe another consultant, if it's another contractor, there still could be some inconsistencies to how benefits have been evaluated using those two approaches. So this could work in an ideal world, but has yet to be applied. I would be quite interested to see what happens when that actually gets applied to a real case study. Unfortunately, current policy still doesn't favour programs, as projects are very much focused on, especially within transport and main roads, as it is very much a project-focused industry, and often things are looked at in isolation and pushed through very quickly. Again, it's a lack of planning, I think, is a real issue within the organisation. And if you go to more of a planning base, program evaluation is a far stronger approach to go about it, even if you're using your simultaneous approach, which may not be 100% accurate, but it still gives you those relationships between your projects that are not currently achieved. So policy changes are going to be required in order to actually bring about more programs effectively. And then we can discuss in detail a bit more about the approaches that should be applied. But this seems to be something that's a little way off at the moment anyway. The next big program that's coming up is the Bruce Highway Action Plan. And at the time that this was presented, the Bruce Highway Action Plan had not actually gone ahead. Since then, though, I can actually say that it was done. It was quite an interesting case study. This was actually presented in another of my presentations, which was the year afterwards. And this will be the next presentation that I'm going to give in the series. I'm going to talk about how program evaluation was actually applied to the Bruce Highway Action Program. So that should be very interesting, so stay tuned to that one. I have now come to the end of my video presentation of my paper on program evaluation that was presented at the 25th ARRB conference. I'd now like to summarize some of the key points of this paper and of this presentation. So why do we need program evaluation? Put simply, there are too many projects to evaluate in significant amount of detail if we looked at them individually. As we're looking at a road and transport network, there are many, many projects, and that's particularly true of Australia and as Queensland as a state of Australia. Another thing is as well that many of the projects are actually interrelated to each other as they all belong to the same part of the network. And some of the benefits and costs relating to those interrelationships are not picked up looking at projects individually. You may have, for example, a project that doesn't have many benefits by itself, but contributes very greatly to the big picture. You may also have 5 or 6 projects that seem to perform well by themselves, but there's a certain amount of redundancy where maybe only 2 or 3 of those projects are actually necessary because there's an overlap of benefits which hasn't been picked up because they're not part of a program. We've also looked at a number of approaches to this as well, number of approaches to program evaluation. We came up with the simultaneous approach and the sequential approach. And both of these rely on the concept of maximizing benefits for capital, a certain amount of capital expenditure. So you want the highest benefits for that amount of dollars there. So those two approaches have contributed to that. We've demonstrated those approaches with a number of case studies. So you had the Bruce Highway Overtaking Lane program, and we also had the Warrego Upgrade program as well. The Bruce Highway Overtaking Lane program actually utilized the simultaneous approach, where projects were ranked within the program based on that. And we had the Warrego Upgrade program, where projects were already ranked according to some other criteria, possibly multi-criteria analysis, then were investigated using the sequential approach, which is actually used to re-rank some of the projects. We looked at the pros and cons of the simultaneous and sequential approach, and also the methods that we use to combine them. So, for example, you may have additional benefits by combining the sequential approach and the simultaneous approach. That would be having the simultaneous approach leading into your sequential approach. So your simultaneous approach actually ranks the projects, and that ranking then feeds into the sequential approach, where you have your final analysis and your final results. So what do we have at the end of all this now? We have a way forward for program evaluation, and potentially we have a good case study coming up with the Bruce Highway Action Program, or Bruce Highway Action Plan. That's actually already been in place, though when this presentation took place at the time, we didn't know the results of that, but that is another presentation. So I'd like to thank you very much, and I'll be presenting a few more papers coming up soon. If you like today's video presentation, just click the like button and the subscribe button, and I'll be uploading several more videos in the weeks to come. Again, within the same series, videos relating to the transport conferences, as well as several other videos also relating to economics. If you want to find out more about today's paper, just go to my website at spectrumecons.com and you go to the research paper, just click the link there and you'll get the paper in full. Again, thank you for listening. Goodbye.